Hello friends, a very good hello to all of you who would be watching this little presentation. Um, so now we are already aware of, most of you are already aware of Python, which is a great language which is used in today's uh, which is used for by most companies for their implementation. We all know that Python is very easy to learn, implement. So most of the companies have taken up this particular software. It is used in machine learning basically, and gaming and many others. So now let us see a little bit about the extension of Python. What more does Python has to offer? You can see that today we will be learning about sci-fi. Rhymes a little bit with sci-fi, the Hollywood movies that we all are already excited about. So today we will be learning a little bit about sci-fi. So let's what does it have to offer? So now let's first quickly dive into the objectives of sci-fi. So these are the things that we would be discussing. These are the what is the sci-fi, the history of sci-fi, why use sci-fi, Numpy versus sci-fi, PiPI packages, sci-fi installation, sci-fi optimize and minimize, and we will be looking at a couple of programs. Now, to begin with, what is sci-fi? Sci-fi is firstly it's an open source scientific library of Python that is distributed under Berkeley Software Distributed License. It is used to solve the complex scientific and mathematical problems. It is built on top of Numpy extension, which means if we import sci-fi, there is no need to import Numpy. Sci-fi depends on Numpy, including appropriate fast n-array manipulations. It runs on popular operating systems and provides many user-friendly and effective numerical functions for numerical integration and optimization. So, what does the library support? It supports integration, gradient optimization. It supports a few special functions, differential equation solvers, and parallel programming tools. We can say that sci-fi implementation exists in every complex numerical computation. Sci-fi is a data processing and system prototyping environment similar to MATLAB. It is easy to use and provides great flexibility to scientists and engineers. Before we get we go to the next slide, let's look at the history of Python and the sci-fi in fact. Python was expanded in 1990s to include an array type for numerical computing called numeric. This numeric package was replaced by Numpy. That was in 2006. There was a growing number of extension modules and developers were interested to create a complete environment for scientific and technical computing. The developers merged the code they had written and called this new package SciPy. The newly created package provided a standard collection of common numerical operations on top of Numpy. Now, why use SciPy? SciPy contains significant mathematical algorithms that provide easiness to develop sophisticated and dedicated applications. We already mentioned it's an open source. Since it's an open source library, it has a large community across the world to the development of its additional module, and it's much beneficial for scientific application and data scientists. Now let's see what are the small differences between Numpy and SciPy. They are both used for mathematical and numerical analysis. So what's the difference? Numpy is suitable for basic operations such as sorting, indexing, because it contains array data, whereas SciPy contains all the numeric data. Sorry about that. Okay, there we are. SciPy contains many functions that are used to resolve linear algebra, Fourier transforms, whereas SciPy library contains full-featured version of the linear algebra module as well as many other numeric algorithms. Please note, remember that if you're doing the scientific computing using Python, you should install both Numpy and SciPy because many features belong to SciPy rather than Numpy. Now let's take a look at some of the sub-package SciPy has to offer. Now there are quite a few of them, around 16 looks like. So the first one, SciPy cluster, you can see that the cluster algorithms are used to vector quantization. Constants, wherein they represent physical and mathematical constants. Then Fourier transforms, integration routines, interpolation, linear algebra routine. It's used for data input-output. The n-dimension image, orthogonal distance regression, optimization, which we will be discussing a little later. For signal processing, sparse matrices and associated routines, spatial data structures and algorithms, special functions, statistics, and it's also used as a tool for writing. Now, let's look at, we get into the nitty-gritty details of what SciPy can do. First of all, obviously, we need to install, we need to get it working, right? So so first of all, what do? We, there is this file called getpip.py. So first of all, you need to install pip to even install SciPy. So install getpip, and then you navigate to that particular folder wherever you've installed it, wherever you've downloaded that, and you just, as simple as it gets, you just run the command python getpip.py, and that's it. pip is now installed. Half the job is done. Then, coming to the last thing, what you got to do? You install PiPI using this pip, whatever you just installed. So, you from the command prompt, you simply say pip install PiPI, and that's where PiPI is installed once and for all. So you can install many packages using this pip manager. Basically, it helps us to install. You can install some of the packages that we will be discussing a little more. You can install Numpy. You can install. Then a little later, we will be looking at one of. In one of the programs, we will be looking at Gecko, right? Which is also used for a package which is used for scientific calculations. So now let's see. PiPI Optimize. The Optimize package provides various commonly used optimization algorithms. This module contains the following aspects: global optimization routines, that could be the brute force, then unconstrained and constrained minimization of functions, that's minimize function using various algorithms, least squares minimization algorithms. So we have a couple of functions here, at least least square and curve fit. So now let's get into a little bit of programming. Let's take a look at this particular function, and then let's see how PiPI can be used to minimize this particular function. So what is the objective? The objective is to minimize, you can see the function there, x1 into x4 into x1 plus x2 plus x3 plus x3. And what are the equations? So subject to x1, x2, x3, x4, they all the product should be greater than or equal to 25. Also, which is the second constraint, x1 square plus x2 square plus x3 square plus x4 square equal to 40. So, and we have bounds out there, right? You can see all of them should be between 1 and 5. And we have initial guesses for those particular values. That's x0. So 1, 5, 5, 1. That's x1 can take the value 1, then x2, x3, and x so those are the initial x1, x1 is 1, x2, x3, x4. They take values as 5, 5, 1 respectively, right? So now just we'll see how we do the programming in Python using PiPI. So now just let's quickly trace this particular program. Let's quickly take a look at this program and see what it has to offer. So now from Gecko import Gecko. So from that particular package you import Gecko, and then from import Numpy, and then you now as we just mentioned a little earlier, what's Gecko? It's a Python package for large-scale optimization. So now what are they doing there? M is equal to gecko. That means to say they are creating an object, and then they are defining the parameter, the value is equal to 40. Why is that 40? You can see that x1 plus x2, that's one of the constraints, that's equal to 40. And now they initialize the variables first, and then as we just discussed, the initial values which x1, x2, x3, x4 they take up is 1551. They are setting the lower bounds, the upper bounds, and the equation. So that was the constraint that the product should be. Let's take a look at that constraint again. The constraint is should be greater than or equal to 25. So that's what they have programmed out here. And x1 square plus x2 square plus x3 square and x4 square should be equal to 40. That's 40, right? Yeah. So, okay. So, and what was the objective of this particular function? The objective was x1 into x4 into x1 plus x2 plus x3 plus x3. Okay. And then we set the I mode, that's to a steady state optimization. So what's this I mode? Each problem type, so it basically defines the problem type. Each problem type treats variable classes differently and builds equations behind the scenes to meet the particular objective inherent to the particular problem type. Okay? Let me say that again. I mode, it defines the problem type. Then wherein each problem type treats variable classes differently and builds equations behind the scenes to meet that particular objective. So now that's finally what we get. So m dot solve, the solve function, basically when we call that function, we get the values of x1, x2, x3 and x4. So I don't have Python installed on this laptop, unfortunately, but run this, follow the instructions, install pip and PiPI. It's as easy as it gets. Then run this program and you will get your output. You will get the values of x1, x2, x3 and x4. Let's go ahead. Okay, next, what do we have? So next we have, I'm sure you must have heard of the knapsack problem in your data, in your design and analysis of algorithms, right? You have greedy knapsack, you have dynamic 0-1 knapsack. So let's take a look. So what, I mean, the picture here says it all. I mean, you can see that the purpose of, what's the purpose of this problem? Let me just do a quick recap of what the knapsack problem is all about. The purpose of the knapsack problem is to select which items fit into the bag without exceeding a weight limit and of what can be carried, right? We solve the problem with an integer programming solver by setting up each item as a binary variable, 0 or 1. The zero decision means you don't put that item in the knapsack, right? And while a 1, obviously you take that item. So now, so those are the items. You can see there's a towel there, a hammer, a wrench, and a screwdriver. Okay. So now you can see that table there, and you can see the values and the weights. So now how do we optimize, what's the optimization formulation? I is equal to 1 to n, you have to maximize vi xi, correct? And you have, and what's the constraint? Subject to wi xi should be lesser than, in this case, that's a big W, correct? Where an xi is either 0 or 1, okay? Okay, now let's take a look at the program which was written for this. Now again, we import the Gecko package, and you can see that we have those 4 items, and the values and the weights are mentioned out there in the program 11836 and 3574. We get the length of how many items we have, and then we create an object of type Gecko, and we initialize the variables, and then you can take a look. We mentioned the lower bound, upper bound, and objectives. We mentioned the objectives, right? So when you can see that in the objective obj function, we have sum of vi xi for all the items. We know that the limit is 14, right? So the knapsack can hold a weight of 14. And then the equation. So the equation, we know that that particular weight and that for that particular item, it should not exceed 14, correct? So that's what they mean by that. Wi into xi for all those items should not exceed 14. It could be lesser than or equal to, correct? So then we optimize it with the APOTT problem solver, right? Wherein, and then we use the solver, we initialize it to 1 first, and then we call the solve method. And now we can print the value of the variables. So if you print the value of the variables, you can this that's you would get as to which one is taken into the knapsack and which one is left out. Okay. So that's about it, ladies and gentlemen, and my dear students. So this is what we learned today. PiPI history, why use PiPI, Numpy PiPI packages installation, optimize and minimize, and we looked at a couple of programs. Okay. All right. Thank you so much for listening so patiently. Let's hopefully we'll again meet up and with a little bit of more learning on SciPy. Okay. All right. Thank you.